Namaskar. Welcome to this channel, Dr.ARM's Chemistry. We were discussing this theories of acids and bases. And next point in this theory is acid-base strength. So by this time we have seen variety of acids and bases, and number of times the question of strength of acid and base arises. And in that case we should understand what are the strengths of acids and bases. So in this case, first point is measurement of acid-base interactions. So for this purpose, we should know that the interactions between acids and bases can be measured in number of ways, and by each method we can obtain one type of information. So one type of experiment or method provides us one type of data, and another type of method provides another type of data, and all such information can be collected and used to interpret about the structure of molecule, strength of the bond, strength of the acid, strength of the base, and what is the reaction or interaction between acid and base, whether after the reaction of acid and base, whether there is formation of a product that is adduct or not, and how much is the adduct stable. So in this way we can obtain variety of information by following suitable methods. So there are different such ways by which we can obtain the information, and one of this information can be obtained in terms of measurement of or measuring boiling points and melting points. Boiling points and melting points. So there is change in the melting point and boiling point when the product is formed or the reaction is taking place between acid and base. So by observing the melting points and boiling points, we can interpret what is the nature of bond present in the between or produced between the acid and base. For example, if we consider the water, it is obtained from the reaction between H plus and OH minus. Here, this H plus is a Levy's acid, OH minus is a Levy's base. Then we can have similar examples, that is, we can say H2S, where we can have H plus and SH minus also. Here also we are having this Levy's acid and Levy's base. Similarly, we can have number of such examples where we can have this structure like this. So for example, these are alcohols. Here also we can find that it is obtained by interaction between H plus and OR minus. So here this H plus is Levy's acid and OR minus is Levy's base. So the actual melting points and boiling points of these products, that is H2O, are more than expected. We know that boiling point of water is 100 degrees centigrade, and if we compare this with H2S, this water is highly stable at room temperature and pressure conditions, whereas H2S exists in the gaseous state. It means boiling point is much less. So this is because the interaction between H plus and OH minus is very strong. The strength of the bond produced between H and OH is also very strong, and that is why it is stable. But in case of this H2S, we are having Levy's acid H plus and Levy's base SH minus. The interaction between these two is comparatively much weaker here. and that is why H2S is relatively less stable. Similarly, alcohols are showing higher boiling points than they are expected if we compare their boiling points with parent alkanes. So such behavior is very important in order to understand the structure. Similarly, we can have another example of BF3 NH3. Here we can have this Lewis acid and this Lewis base. So here this Lewis acid is also very strong, NH3 Lewis base is also very strong, and therefore their interaction is also very strong and it gives more stable product. So the strength of the bond between this boron and this nitrogen is also very strong, and that is why the product is much more stable. Next method is direct calorimetric methods. Direct calorimetric method, or this is also temperature dependence. This is also a measure of temperature dependence of equilibrium constant. Of the formation of adduct. So it gives us the information about the enthalpies and entropies of the reactants, that is acids and bases. So this gives information about enthalpies and entropies of the acid base reactions. Third is gas phase measurements. Third is gas phase measurements. So, in case of formation of a protonated species, it provides similar information as we have seen earlier, that is enthalpies and entropies. So, thermodynamic data is obtained in case of gas phase measurements. Next is infrared spectrum. Infrared spectrum. So this infrared spectrum is obtained in case of various functional groups, and these functional groups are showing their corresponding the frequencies of radiations that are absorbed by the substance. That is informative, or this information or data can be used to compare whether there is formation of the product or not. So this information shows that the various bond movements, that is the stretching or bending of the bonds, shows that, or that is correlated in terms of the frequency of radiation or frequency of radiation absorbed. And depending upon that, we can correlate the bond with its environment. For example, if we consider the carbon monoxide, it has stretching, CO stretching taking place at 2143 per centimeter, whereas If we take another example, NiCO4, here we can have this CO stretching at 2050 per centimeter. So 2058, we can show it more accurately as 2058 per centimeter. So this shows that, means if we consider this is the independent, this is separate molecule carbon monoxide. So when it is existing as an independent entity, then it has stretching like this taking place at about 2143. But when it is complex with nickel, means it is not independent or separate substance. So carbon monoxide is complex here, means it is strongly bound with nickel. And in that case, the stretching takes place, CO stretching takes place at 2050. So there is change in the absorption frequency of the radiation. So this confirms the formation of such complex or adduct. Then next is measurement of NMR, nuclear magnetic resonance. Nuclear magnetic resonance. That is the force constant, we can say. Force constant. So it also coupling force constant, we can say. Coupling constant, we can say. In other words, we can say coupling constant. So this coupling constant provides us similar indirect measurement of changes in the bonds and formation of the adduct. So here we can have such number of examples. NMR is specially observed in case of molecules in which there is a proton and C13. So there are nuclei having odd number. There is one proton, and in this case there are 6 protons and 7 neutrons. So these protons and neutrons will be converted, means their vibrations, or we can say energized state, can be recorded in terms of the spectrum, and from which we can obtain the suitable data. Then another is UV visible spectroscopy. UV visible spectrum. So this information can also show the change in energy levels in a substance when interaction is taking place. So such change in energy levels can provide us information about the molecule, and whether that molecule is showing conversion of reactants, that is Lewis acids and Lewis bases, to form the adduct or not. If the reaction is not completed, the suitable data will not be obtained. So in this way we can obtain variety of information, and which is used wherever it is required in the determination of structure or bonding or changes in bonding interactions. So with this we will stop our discussion. Please subscribe to this channel and press bell icon and like button.